We're going to go over simulations a bit. It's something that can be a bit tricky for students. So I wanted to go over how you can create a simulation for a given situation. This is one I'm just going to work with based on some real life stats that I encountered. As it's the holiday season right now, I came across this statistic, which I thought was interesting. I was reading it in a retail magazine or retail publication, believe it or not. It told me that right before Christmas or right before Thanksgiving, excuse me, it said that 45% of Americans intended to shop on, we'll say, Black Friday, we'll say weekend and Cyber Monday during that kind of like 3-day stretch. 45% of Americans were intending to shop, which I'll be honest, it seemed kind of low to me, but I'm going with it, whatever. So based on what I've read there, what I did was I pulled one of my classes to figure out, okay, how many of you plan on shopping for Black Friday? And when we did that, again, it wasn't just Black Friday, it was Black Friday that weekend and Cyber Monday. We ended up with, let's see, quite a few kids. I was quite surprised. We ended up with about 13 out of 20 students intended to shop. And we thought that, hey, it seems kind of high. If that real statistic is 45%, how likely am I to get 13 out of 20 people to say that they intend a Black Friday shop? And again, I'd say it was a fairly random cross section. We figured out how many kids were employed, how many weren't, how many had siblings and whatnot. And believe it or not, it was a fair resemblance of what you'd expect from the American population. It was not that far off. So I said, let's create a simulation for this. And that's what we're going to do. We're going to try and simulate this. So that way we can see, like, if this is really true, that 45%, if I were to ask a group of 20 students, or 20 people, how many of them have been shopping, what should I expect to see? How likely is it that I'm going to see 13 out of 20? Is it likely? Is it unlikely? So what we did was we went with 45%. We started with that. So 45% of Americans intend to shop. So someone said, how about we use a random number generator? That's always a great idea for a simulation. So we're going to go with an RNG, a random number generator. We're going to assign numbers 1 through 100. Out of those numbers 1 through 100, numbers 1 through 45 are going to represent shoppers, people who shop, who said they're going to be shopping, over those days. The rest of our values, 46 to 100, those will represent people who don't, or don't plan on shopping, not shopping. Based on those values, I'm going to randomly select 20. And we're going to see how many of those 20 end up being a shopper. So I'm going to take out my calculator here. And I'm going to try and keep track. So let's see, I'm going to go to probability. And I'm going to clear everything. Graph and Calc 83, highly recommended. I think it's an awesome tool. Whoops. So I'm going to get out of here. That's all right. I'm going to go hit my math button. Probability, rand int. I could do number of trials, but I'll be 100% honest. I don't access those numbers very well. So I just like to do it one at a time. So I'm going to go 1 through 100. I'm going to keep track. I'm going to draw 20 numbers. I want to see how many of these are going to give me shoppers. I'm grabbing a marker to keep track. So my first number is 85. That's someone who didn't shop. So I'm going to mark that as, and I grabbed the Sharpie, not the smartest move. All right, not a shopper. 40, shopper. 79, not a shopper. 80, not a shopper. 92, not a shopper. 20, shopper. I'm up to 6 numbers, you'll see. 34, shopper. 77, shopper. 28, shopper. Oh, 77 wasn't a shopper. Excuse me. 28 was. 56, not a shopper. 48, not a shopper. Remember, I want 1 through 45. That represents someone who's a shopper. 63, not a shopper. I just want to see how many values I'm up to now. All right, I am up to 12, so I need 8 more numbers. 37, shopper. 52, not a shopper. 96, not a shopper. 92, not a shopper. Notice that I don't care if I repeat here, just because these numbers represent our population, like 45% are those who say they shop. The rest of them are going to be those who don't shop. So it really doesn't matter if these numbers are repeating. They don't necessarily represent unique individuals. So let's see, I just want to see how I'm doing on my numbers here. say I've got 4 more. Not a shopper. Not a shopper. Shopper. And I think I got 1 more. Not a shopper. Okay. So based on my numbers here, I ended up getting 6 people who were shoppers. So what some kids would be inclined to do, or some, people who aren't comfortable with simulations, they would just draw a nice old number line right here. They go 0 to 20. Notice I'm going to go kind of basic here with my number line. I always recommend doing that. Don't go crazy drawing perfect number lines. It's not worth it. As long as you have the basic labels, you're in good shape. We'll have this represent number of shoppers. I just did a simulation of 20. And when I did that simulation of 20, I ended up getting 6. Okay. Am I done here though? No. The point of simulations is you do it over and over and over again. You do as many simulations as you can. So obviously, I'm not going to make you sit here while I do multiple upon multiple simulations. I'm just going to do another round so you can get a chance of what it looks like. So again, I'm going to go with 20 numbers. I shall clear it. And on my desk here, I'm going to keep a tally. Shopper. 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 Not a shopper. Shopper. I'm up to 5. Shopper. 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 Not a shopper. Shopper. Not a shopper. Not a shopper. Not a shopper. Shopper. Not a shopper. How many am I up to now? I'm almost done. I got 5 more. Not a shopper. Not a shopper. Not a shopper. Shopper. Not a shopper. Okay, I'm up to my 20 now. I'm double checking. Yep, I've done 20. And this time I had, let's see, I had 9 shoppers. So then I would go to my table here. I'm going to put a 9 here. I would keep doing this. Do it 20 times. See how many shoppers I get? Mark that on here. Now, ultimately, what we should notice happening, right? You should be noticing you're not going to be getting the same number each time. The first time I got 6 shoppers. Next time I got 9 shoppers. Maybe the next time I do it, I get, who knows, maybe I get 14. Maybe I get 2. Maybe I get 19 at some point. Maybe I get 11. You get the idea. I'm going to be getting a bunch of these. But what you should notice happens, this will happen as a matter of fact. If you look at it, it's 45%, right? 45% of 20 ends up being 9. The more I do this, I'm going to notice a lot of values right near 9. Does that mean they're all going to be 9? No, of course not. I might get a bunch of 10s, maybe some 8s. Maybe I'm going to get some 9s here too. But what you're going to notice is that ultimately you're going to get a distribution that probably looks something like this, where you're going to get a bunch right in the middle, right near 9. Again, the more often you do it, you're going to get more 9s. This is what's going to happen. You're going to get really close to 9. You're going to get something that looks like this. So you're going to get them really centered around that 9. You're going to get most of your shoppers are going to be centered right around 9. And you are still going to get those, examples where it's going to be really low or a lot higher than what you expect. Now, that's what the law of large numbers tells us. It tells us the more often you do this, essentially, the average number of shoppers is going to be based on that theoretical probability, what we have here. Based in theory, based on what we know, 45% of Americans are, said they're going to be doing shopping that holiday weekend. That means if I ask a group of 20, I should be getting 9 a lot. And that's what's going to happen the more often you do it. Am I going to get 9 every time? No, of course not. As you can see, in some cases, I'm going to get some really low ones. In some cases, I'm going to get some really high ones. But most of my values are going to be right around 9. They're not always going to be 9. But if I average out all these, I should be getting an answer of 9. Now, what I can also do as well, because I'm going to do a lot of, I'm going to delete a lot of these. I'm going to try and just go with what I have. Another great example of this, I did all my other ones in blue. Oh, wow. I'm going to go with the 2 that I did, 6 and 9. So if I do 6 plus 9, I think that was what I ended up having. I might be wrong. I think that's what I ended up having, over 40. To being 15 over 40, because 40 represents the total number of numbers I drew. I did 20 and 20. 15 divided by 40, don't shame me. I have to do this on a calculator. 0.375. That's really, I mean, it's fairly close to that 0.45. The more often they do it, if I take all of my trials and combine them together, I should get a probability that's really close to what it actually is, that 45%. So this is a good example of a simulation. Again, what I did was I just went with this value that I found, this statistic that 45% of Americans intended to shop on Black Friday weekend, or, that holiday weekend. I asked a group of students in my class, 20 of them. I ended up getting 13 out of 20 students. I said, let's test it. Let's see if it's possible. Now, what I might end up finding is, again, I'm going to draw a bunch of X's here. You should be doing these simulations out. I'm just showing you what could happen when you do these simulations. Chances are what you're going to notice is, okay, I do get 13 sometimes. It's not very often, but I do get 13 or more. So it is possible that this could happen. It could happen in a group of 20 people that, even though, my parameter for my population is 45%, that 45% of Americans are, holiday shopping, I could still get a group of 20 that, I could get some high values here. Maybe a lot of them in that group of 20 shop. That still is possible if it really is 45% of Americans who shopped. So I just wanted to go through an example of how you can do a simulation. So if you have a project or you have to do something in class that involves simulations, you can use this as a model. Just think about, what's something about your population, then go with a small group within that population, see what's happening. Like what I did was my population was like the American public. The small group I chose was my class. And then within my class, I saw something. And then I simulated, asking 20 people based on my class size to see how often I might end up getting what I saw in my class based on that 45% from my American population. Hopefully this helps you.